So we start off with momentum and force with respect to momentum, and just a basic bit of impulse. So momentum, and we know that E is directly proportional to S, that the linear momentum is directly proportional to the mass, and it is also directly proportional to the velocity too. So if we combine the two propositions, it is proportional to the product of mass and velocity, the linear momentum. And if we convert it into an equation and we put the constant of proportionality k, so it becomes p is equal to kmv, where k is equal to 1 in SI. Okay, in the SI units, k can be assumed to be 1. So p is equal to mv in this case, and in the vector notation it is mv with the vector sign. And force in terms of momentum, as we know that F is equal to ma, and we know that acceleration is equal to df minus vi by t. So F is equal to m df minus vi by t. F is equal to mvf by t minus mvi by t. Yes, which means what? F is equal to pf, the final momentum, by t minus initial momentum by t. Or it's basically delta t here to be more accurate. So F is equal to pf minus pi by delta t. Yes, so F is equal to delta p by delta t. So this is the form we're looking for, force in terms of momentum, and it is understandable. And impulse, we remove this and we start working on impulse. So for impulse, we have this J is equal to F delta T. It's the product of force and differential time. It gives us the impulse J. And F, we know that it is equal to delta T by delta P by delta T. Okay, so we can substitute this in one. So J is equal to delta P by delta T dot delta T. So now we can cancel out delta T's. So J is equal to delta P. So this is the second form. The change in momentum is equal to impulse, and change in momentum means mvf minus mvi, which means m into vf minus vi. So mass times change in velocity. So this is also an interesting form which can be put to use. and something about this absolute potential energy, but we will discuss that later because of its extended form. And and now we work towards these basic forms for waves, and maybe the Laplace correction, but we will see because Laplace is time taking, so we will basically discuss the form of wave. Mathematical form of wave. Okay, so waves, and when we say waves within the domain of mechanical waves, first of all we have sound waves in mind. Okay, so there is a proposition, but I will put that into discussion later after reaching a certain point. To begin with, velocity is the modulus of elasticity by the density under the root. This is the basic proposition to begin with, and in some other video we can have a segment on it as well. So